There we go.
All right, thank you. Hello, everyone. Good morning. Welcome to today's APAC community call. So today we'll be featuring 2 mini tutorials. So first, OHDSI news. I'm not sharing the OHDSI.org page, but just want to, again, let everyone know about a couple dates. So the upcoming European Symposium is going to happen. It's going to take place on June 18th. So if anyone is going, I know it's kind of coming up and the registration probably has expired, but that's happening. And then the other dates that I want to bring to everyone's attention is that June 24th is going to be the abstract submission deadline for the Global Symposium on October 14th. So if anyone is kind of working on a OMAP related paper or anything like that, so this will be a great chance to submit your abstract to the Global Symposium, and deadline is end of June. The other dates, as Professor Jason Xu has announced in our last call, so just FYI, we will be having our APAC Symposium this year in Taiwan from November 12th to the 13th. So that's just a couple dates I just want to mention again. And then for the APAC Symposium, there will be more information coming up as for the registration and deadlines and important dates. So that's all to come. So without further ado, today's our main agenda are 2-minute tutorials given by our first one will be on concept sets and cohort creation in Atlas by Kyulee Jeon, and then the other one will be Atlas characterization by Yizhi from Singapore. So first one, I would like to introduce Kyulee, research assistant from Yonsei University Health System, and is working for Dr. Senchen Yu in the biomedical informatics department. So her research interests are applying the artificial intelligence technique to the biomedical data using OMAP CDM. So Kyulee, would you like to start sharing and presenting the mini tutorials?
Yes.
Cool. I will stop sharing. Thank you.
Can you show this
Yes.
screen? Okay,
yes.
I'll start. Hi, I am Kyulee. Nice to meet you all. It is an honor to participate as the first volunteer of this mini tutorial. I'm in charge of concept set and cohort creation part, and I'll start. Before we go in, let's take a quick look at the cohort in OHDSI. In OHDSI, cohort is defined as a set of persons who satisfy one or more inclusion criteria for a duration of time. In OHDSI, 3 building blocks are used to define the cohort: cohort entry event, inclusion criteria, and cohort exit, respectively. Let's take a look. At first, cohort entry event defines the time when people enter the cohort, the cohort index date. Inclusion criteria are applied to the initial event cohort to further restrict the set of people. Each inclusion criteria can be evaluated to determine the impact of the criteria on the attrition of persons from the initial event cohort. And in the OHDSI tools, our criteria are formulated as inclusion criteria because using exclusion criteria often introduces double negatives. Instead, any exclusion criteria can be formulated as include people with 0 occurrence. At last, cohort exit event signifies when a person no longer qualifies for cohort membership. The standard components we use to assemble these criteria are the CDM domain and the domain-specific attribute, concept set, and the temporal logic. As you are building your cohort definition, it may be helpful to think of domains like building blocks. And before you start to create a cohort definition, you need to assemble your concept sets to apply to your criteria. So let's look at the concept set together first. In this session, we took acute myocardial infarction as an example. A concept set consists of a list of concepts with following attributes: exclude, descendant, and mapped. For example, a concept set expression may contain two concepts as depicted in the table. As shown in the right figure, this will include myocardial infarction and all of its descendants, except old myocardial infarction and its descendants. In total, this concept set implies nearly 100 standard concepts with the descendants option. Now let's create a concept set on Atlas. Access Atlas and click Concept Sets in the left menu. You can see the list of concept sets that have already been created in below. And we will make a new concept set, so click New Concept Set in the upper right corner. The first step is to name and save. You cannot use a name that already exists. I'll enter its name, acute myocardial infarction, and save. Now that we've made the frame of concept sets, but there is no included concept, so we'll go to search to find a list of concepts to put inside. Search for the desired concept. I will search for myocardial infarction. If it shows nothing, we need to search synonym. I think we can proceed as it is. Then you can filter domain as condition and the standard concept as standard. Then find the concept you search for. RC and DRC mean record count and descendants record count. There are 306 descendant record counts of this concept. It means more specific concepts are persistent in the data. I click on myocardial infarction at the top. We can see the details for the concept. Then let's check hierarchy. Let's check out the hierarchy. We can view the parents, current concept, and the children of myocardial infarction. Let's see. And you can see there is old myocardial infarction that is not included in acute myocardial infarction. I'd like to add all of them except for the old myocardial infarction. So select current concept with descendants and add to concept set. Then select old myocardial infarction and exclude that with descendants and add to concept set. We included all the list of concepts, so click to concept set again to go back. As you can see, it is configured as desired. So let's save it. Then we completed to create our concept set. We only selected two concepts, but if you look at included concepts, you can see that 100 concepts are included. You can also check which source codes are included in a concept set. For example, filtering to ICD-10 shows 12 source codes. Now, if you press X button to close the window, you can see that our result has been created in the list. Back to our slides, I'll explain cohort definition first, and then I'll show you how to implement it in Atlas. For example, let's create a cohort of acute myocardial infarction, 7 periods, 180 era in the OHDSI phenotype February. When starting in Atlas, click on the module and create new cohort as before. Name it first and save it. As you know, there are 3 building blocks used to define the cohort in OHDSI. cohort entry event, inclusion criteria, and cohort exit. Let's look at how these criteria are figured in Atlas, starting with the first block. Look at the first block. In this example, the cohort start date is defined by the first diagnosis of acute myocardial infarction. So we want to choose a condition occurrence criteria and import our concept set. To specify our definition, we need to click Add First Diagnosis. When you add criteria, it appears as follows. Despite its appearance, the X is not intended to mean no. It's a delete button. Also, select Limit Initial Events to earliest event per person, and with continuous observation were explained in the next slide, because it could be confusing. OHDSI has the concept of observation period. This allows you to determine if the patient is really observable in a specific period of time. Let me give you an example. There is a criteria with continuous observation at least alpha days before and beta days after event index date. There is a timeline of person A and person B. At this time, person A was able to observe continuously for alpha days before the initial event and beta days after the event. On the other hand, person B couldn't be observed continuously because he or she went abroad for a few days, so that record was missed. In this case, person A is included as the initial event cohort, while person B cannot be included. I hope this example could be helpful. In our example, entry events do not require this criterion, so we set it to 0 for each. We will add the observation period criteria in the inclusion criteria. Let's see it. The second block, inclusion criteria, are applied to the initial event cohort to further restrict the set of people. On the figure, we can see inclusion criteria with at least one occurrence of observation periods with the following criteria. The above period could be plotted in red in the following figure. At this time, the start and end of the observation period must be included in the period, like this. If there are patients whose observation event starts outside the criteria period, the patient is excluded as violated the inclusion criteria. That is, we created inclusion criteria that should be observed for 365 days before an entry event occurs. The third block, cohort exit. Cohort exit can be defined in multiple ways, such as the end of the observation period, a fixed time interval relative to the initial entry event, or through other censoring observation period. In this case, event will persist until 7 days relative to initial event. The schematic is as follows. The explanation is now over. I will show how to configure this in Atlas. Access Atlas and click Cohort Definition module. Then click on New Cohort. Now you can see an empty cohort definition. At first, you need to name this cohort. Let's name it Acute Myocardial Infarction. 7 periods, 180 era. And save it. Now we can proceed with defining the initial cohort event. Click to add initial event. Atlas provides descriptions below each criteria to help you. Since we want to find patients with acute myocardial infarction at first time, I'll add a condition occurrence criteria. The screen updated with our selected criteria, and we need to change any condition to acute myocardial infection by importing our concept set. So click the drop-down and import concept set, and select the concept we made. Then we need to add attribute, and select the Add First Diagnosis, and set limit initial events to earliest event per person. Now we have built an initial event. Let's move to second block. Click New Inclusion Criteria to add new criteria. You should name your criteria. Let's name it as 365-day prior observation. And if desired, you can put a little description of what you're looking for. Once you have annotated this new criteria, you will click on the Add Criteria to Group button. We could add multiple criteria to this. In this case, we want to find observation periods, so we'll select Add Observation Period. We want to specify the event starts between days before and the 365 days before index start date, and add additional constraint. And the event ends between between 0 day after and days after index start date. Limit qualifying events to a list event per person will be maintained. You have now added all of your qualifying inclusion criteria. You must now specify your cohort exit criteria. Cohort exit will be set in 7 days from the initial event. Click the drop-down and select fixed duration related to initial event, and select start date and to 7 days. Then specify your class gap size to 180 days to follow the phenotype. We have now successfully finished creating our cohort. Make sure to hit the Save button. It's done. You can now use the Export tab to share your cohort definition to other collaborators in the form of SQL code or JSON files to load into Atlas. And it's the end of my presentation. Thank you for your listening.
Cool, thank you. Thank you, Kyulee. I really like the graphs because I think that really shows the, how we created a cohort, and then you have the, the previous, like what's the days, before, after, because it's so easy to get confused by that, like in a deck. I think which we will be sharing, afterwards with everyone as well. But I think the graphs making the timeline quite clear. So any questions from the audience?
Yes, can you hear me?
Yes.
Yeah.
Oh, this is going from the medicine at the Baltimore. So because we just built this OHDSI OMAP with my hospital data set. One question is I have the problem is we try to find the patient cohort based on the care site. For example, I work for this hand center. We try to find the patient who visit this hand surgery center. Because there's no location concept ID, to for the filtering this patient. Is any way to get the patient cohort based on the care site ID or just a location ID? I don't know if anyone have any experience.
With the care site ID or?
Yes, for example, one hospital built a OMAP data set, right? there's maybe different department, for example, department of surgery. So we need to find, how many patients visited this surgery center, because maybe they have multiple 10 surgery centers. So we need to find the patient visit surgery center A.
Okay, so so we do have, if you really want to go down like to even granular than that, because for every, like, let's say for every drug exposure, so let's say, Jane got a prescription from Dr. A, who is a dermatologist. So in the drug exposure table, there will be a field called provider ID. So provider, which you can see in the standardized health system. So that means, the clinician. And then from the clinician, the provider is, and then they will see, you can save in the provider table is, whoever that provider is with the ID, and then you can see his or her specialty. So that will gives you, really like, where does this patient got this treatment from? Whether it's a GP, it's a dermatologist, or whichever cardiologist, whichever kind of type of doctors. Can that answer your question?
Sort of. For example, this surgeon X, he just have clinic A and clinic B. So for example, Monday, Wednesday, Friday, they go to clinic A, Tuesday, Thursday, then go to clinic B. So if I want to find this patient visit in clinic B, so it's MPI couldn't be used, to fit
that
this
would be
patient.
care site. Yep, so that will be care site. So as you can see, the provider and care site. So those two kind of care site can say where your basically the hospital or the clinic, whichever it is.
Yes. Yes,
and then,
I know it's use SQL is pretty easy, but use Atlas. I forgot
yes.
it. Yes, Atlas.
Yeah,
SQL is
true.
pretty easy to do it.
Yep.
But Atlas usually it's like the Atlas environment.
It's easier.
I don't find such a filter.
I think there is the care. You can also add care site in Atlas, right? So I see.
Yes, it's like a concept ID. For example, this ambulatory surgery center, but it's like a more general. It's not specific to a specific building or just some nurse unit. Just asking. I know it's not no tool is perfect. Just asking anyone have experience use Atlas to do such as a cohort extraction based on this location. Okay.
Got it. So I think that too. I think for Atlas, it definitely has its limitations as you're going deeper into provider, because it's more focused on the clinical events table, like drug and what's the diagnosis. But as for location, care site, provider, cost, and it cannot do anything cost related to. So it's more focusing on, if you look at the CDM table. Thank you, Kyulee, for sharing this. And it's really, Atlas is focused on the dark, the blue box, basically all the information in a blue box more. It has something in the red box about the standardized health system, but I totally got you. I was literally running a query yesterday myself too, that I was going to the provider things, and you cannot really do that much in Atlas. It kind of has to be SQL.
Oh yeah.
Gong Liang, I would suggest one option. So when you select visit occurrence from Atlas, you can add an attribute, and one of the attributes is called place of service. So, and there's also another attribute called place of service location. So you might want to fiddle around with these two and see if it gives you the results that you're looking for. So that would be my suggestion.
Yes, I think this place really depends how your institute build this database. Sometimes it's not mandatory. Maybe some institute fill this information, but some institute didn't, put the information in this column. For the case, my case is nothing. So
right. So
maybe some, some hospital, put the information in this the place of service or just a location.
Right. So of course, it's gonna depend on how you, ETL your data, right? So
yes, right.
Yeah.
It's
so
not mandatory. It's not a mandatory, for some columns.
Right, you're right. So it's gonna depend on how you map how you ETL your data, and it's gonna differ for every database. So yeah, I hope that answered your question for now.
Yeah, thank you. Yes, I just use a SQL, I never use a second database. I like use original database. So, but it's SQL is complete this task. But Atlas, I just wondering if anyone have any experience, to do this care site searching. Thank you.
No problem. And I see there is another question. Oh, I see Patrick already answered. The question was about when creating concept sets, what's the difference between choosing descendants and mapped when we include the concepts? So Qingyao, I don't know if the answer from Patrick, do you have any other follow-up questions? So in general, the descendants will just have, not only, for example, for ingredient, if you go with, ibuprofen, of course, there will be a lot of, descendants. There will be including Abbott's ibuprofen. There's drug A, brand A, and brand B, brand C. So, by only using, having one central ingredient level and include all the descendants will really save us a lot of work, so that we could have a very comprehensive list of the drug or disease or anything you're interested. So that's really making things a bit easier when picking the concept sets to use. Cool. So thank you so much, Kyulee, for the presentation. And then I will. And then we will turn to the second mini tutorial from Yizhi. So let me quickly share my screen. Right. All right, so next we'll have Yizhi to talk to demo the mini tutorials on Atlas characterization. So Yizhi is a research assistant in National University of Singapore and currently focusing on the healthcare event prediction using statistic model and machine learning methods. So with that, Yizhi, can you start sharing your screen?
Okay, I'll share my screen.
Thank you.
Oh, sorry. I think there's some privacy. I need to exit the Microsoft Team first and enter again. Sorry.
Sure. Yeah. Go ahead. Go ahead. Yeah, we'll wait for you. Go ahead. So Qinyao, yeah, I think Patrick's general guidance would be that we would not use the mapped criteria unless it's absolutely required for your needs. I don't know if I don't know if there are specific cases where I'd use mapped, but yeah, normally we would just use descendants and exclude if you want to exclude specific concepts.
Yes, this is Gonian again. I think in our team, a junior member asked this question maybe last Friday. So for mapped, it's mapped to the invalid data set. It's not standard.
Right.
So usually descendant have all the standard this valid the concept map. For the mapped, it have everything. For example, have ICD-9, ICD-10. It's not SLOMAD. So try not to use mapped if you use it for cross-institutional study.
Correct. I think Patrick just also replied to a specific use case. So yeah, let us know if you have any further questions on this, Chen Yao. Okay, great.
Okay.
Yizhi, are you back? Yeah.
Yeah. Okay, so I'll start show my screen.
Is it working now, or?
Sorry?
Are you able to share your screen now, or is it still?
And share it now. Okay.
Okay.
Yep, we can see it. Thank you.
Yeah, it works.
Can you see my slides?
Yes.
Okay, let me start sharing. So hello everyone, my name is Yizhi. I'm from National University of Singapore. Today I'm gonna demonstrate a mini tutorial about the characterization module within the Atlas platform. So cohort characterization is defined as a process.
So you want to go into a presentation mode? Sorry to interrupt.
Sorry?
Are you want to go into presentation mode of your slide?
Presentation mode?
Yizhi, I think morning means
you need to
press
presentation
F5.
mode. It's it's button this the corner and project.
Yeah, the projecting this slide. We are looking at the of the editing.
Oh. Okay.
If
the
you press
button next
F5,
to the minus this sign symbol. This help project to the screen, whole screen share.
Yeah, the screen share was fine. Sorry that I probably spoiled the thing. My apologies. Yeah, sorry to stress you out. Yeah, there's this tiny projector at your PowerPoint that will full screen your slides. Yes.
Can you see this time?
Thank you. Sorry to interrupt you. My bad.
Sorry, I didn't forget. Okay, so cohort characterization is defined as a process of generating cohort-level descriptive summary statistics from person-level covariance data. So basically, you can use this module to generate the summary statistics of the feature that you selected within the cohort you selected. So in this mini tutorial, I will cover 4 main parts. First, I will demonstrate how to create new characterization and new feature analysis to describe the cohort. And then I will show how to generate a report and go through the report structure. And last but not least, I will show you how to export or import your characterization design. So next I will show a lab demo. Okay, can you see my atlas here?
Yes.
Okay, nice. So we can go into the characterization module by clicking this button on the left menu. So within this page, we can see 2 tabs here. The first one is characterization, where we can create new characterization and run analysis here. The second one is feature analysis. Here we can create our own customized features and import it into our characterization and run the analysis on these features. I will mention how to create feature analysis later, so let's start from the characterization. So we can create a new characterization by clicking this button. And for demonstration purpose, I will show an example that I created earlier. So first, you need to give it a name. And after that, there are 4 parts in the design page. The first one is cohort definition. You need to import 1 or more cohort that you want to run the analysis on. And then after that, you need to import 1 or more features that you want to describe the selected cohort. So, and later you will obtain the summary statistics of these features. And the next section is subgroup analysis. This section is optional, so you can leave it blank, and you can create new subgroup to obtain more information about this subgroup. The last section is feature analysis parameters. This section is also optional and it is seldomly used, so I will not cover it in this tutorial. So let's go back to the top. And you can import the cohort definition that you defined earlier from here by clicking the import button. Okay, so for this example, I will use the type 2 diabetes that defined in the phenotype February as an example. So you can search the target cohort using the filter function. You can select the cohort by simply clicking the checkbox on the left and click import to. After that, you can import some feature analysis. There are already some built-in baseline characteristics within the Atlas platform, so you can directly import them. And you can use the filter to search for the feature, and you can sort the feature list by ID or name. And on the left, you can also sort it by filter with the domain. So for example, I'm interested in some demographic characteristics, so I can click the checkbox to import them. And beside those built-in characteristics within Atlas, we can also create our own features. So let's just exit directly. So we can go to this feature analysis type here to create new features. For example, I'm interested in to compare the hyperglycemia happened after the diagnosis of type 2 diabetes within my cohort. So I will name it as the first thing we need to select the corresponding domain of this feature. In this case, it's under the condition domain. And you can put some text to describe the feature. And then we can click the criteria button to start the design. First, we need to select the analysis type. In this case, it's prevalence. And we'll also call it hyperglycemia after diagnosis. And you can click this button to add criteria. There's a lot of criteria types that you can choose from. In this case, it's under the condition occurrence. So we first need to define the frequency. In this case, I'm interested in at least one occurrence. And then you need to import the concept here. And since I'm interested in hyperglycemia, so I will import the hyperglycemia concept set. And you need to create this concept set earlier. Then we need to define the time constraint. Since I'm interested in the hyperglycemia that happened after diagnosis, so I will change it to 0 days before and all days after the index start date. Then we can save this feature. Click the exit button. And we can then go back to the characterization and add this feature into our feature analysis. Okay, I will leave this subgroup analysis blank first and show you how to generate the report. So you can go to the execution functionality to generate report. You can see there's the data source available, and you can click the generate button to generate report. And after you
Was it just me, or I cannot hear Yizhi now?
Yeah, we've lost sound.
Yeah, me neither.
Oh, okay. So Yizhi, we cannot hear you. Uh-oh.
She's still in the call, maybe. Okay, there.
So my internet I disconnected. Sorry.
Okay, okay.
Lost
Now it's good. Yeah, you can switch back to the Atlas website now. I think. Oh, it's gone.
Can you see?
I can. Yes.
Yeah, we can see.
Here.
Where did you lose me? At which step?
Yeah, you can start here, I think.
Okay, thanks. So I've generated some reports earlier. But I think the public atlas may be a little bit slow. So I will show you the screenshot directly. So after you click the general button and click the view result, you can see a report looks like that. So on the top, there's a filter panel where you can filter your analysis by cohorts, by feature analysis, or by the domain of the feature analysis. And if you scroll down, you can see a big table here. This is the first table, and it contains all the statistical results of covariates. So you can see the covariates name, concept ID, counts and percentage within each cohort you selected, and you can also view the standard difference between these two cohorts. And since it's a large table, so you can search for your target covariates need that at this search function. And you can also export the table by clicking the export button. It will generate a CSV contain the statistical result, or you can export the comparison. And if you select two cohorts at the analysis, the system will render lots of graphical visualization for you to compare the two cohorts. For example, you can see a scatter plot on the right. So the x and y-axis of this scatter plot represent the prevalence of each covariance within each cohort. And each dot here represents one covariance. And the different color of the dots represent different domains of those covariates. So if one dot is far away from this dashed line, so you can easily identify that this covariate made the two cohorts different. And if you use the Atlas platform, if you hover over one dot, it will show you the information about the feature name, the covariance name, and the prevalence at the x or y axis. But it will not show here. And if you scroll down, it will show you the statistical result of each feature analysis you imported earlier. And if the feature is a categorical feature, it will show you a scatter plot like this. But if it is a continuous feature, it will show you the distribution analysis here. For example, it will show you the count, average value, standard deviation, and median value. And on the right, it will render a box plot for visualization. For this example, you can easily tell there is some difference between the first quantile or the median value. Okay, let's move on to the next functionality. Okay. So, and then you can define the subgroup analysis if you need to know the information of it. For this example, I'm interested in people with age greater than 60. Sorry. Then you can click this button to add criteria. In this case, it's under the demographic criteria. And then add attribute, add age criteria, and improve the age criteria. After that, you can save the characterization again and go to the execution page and generate report again. And I will show you using the screenshots. This is how it looks like if you generate the result with the subgroup analysis. So the layout is pretty different than the previous analysis. This time you can see additional columns that show you the counts and percentage within the subgroup that you defined. And in the previous feature, you can see additional rows that contain the information about the distribution information. Okay, let's move on to the next functionality. It's under the Utility tab. So Atlas will automatically generate the JSON file contains all the information of your characterization design. So you can simply export it by click this button to copy the JSON file to your clipboard. Or you can also paste the JSON file here that others send to you by and you can import the characterization design on your own Atlas platform. So with this functionality, you can not only run the characterization analysis on your own computer, but you can also share it with others in the OHDSI community. Okay, so that's all for my mini tutorial. Feel free to ask me any questions. Thank you,
Yizhi. Any questions? I know kind of characterization is quite simple. I think that's really, if you want to take anything like gender, age, the demographic, it's just so easy to do that. And I know you can do that in SQL anytime, whatever you want. But I like personally think, characterization just making our life so much easier. For the basic characterization, it pretty much can cover everything that we need. Cool. So any other questions? Or in general, about the concept sets or cohort or characterization? All right, then I guess that will conclude for today's call. And in next call, we will be kind of again, a tutorial, but more on the instance and prevalence calculation that we really kind of used a lot for different studies. So we will be kind of focusing on those in the next call. And welcome everyone to join again in 2 weeks. So that's for today's call. Thank you so much for joining us. And I will be sending out the deck as well as the recordings to everyone afterwards. And of course, they'll be on OHDSI webpage. Thank you, everyone. Have a good day.
Excellent. Thanks so much.
Thank you.
Thank you.
Bye.
Bye-bye. Have a nice day.